there are several emails from the students asking about the induced EMF, non-conservative electric field produced by changing magnetic field, and how that EMF is produced and what is its relation to the geometry of the circuit. I have several experiments on this. Now, here is an experiment that I will demonstrate and then we will discuss the physics of it. So, I have a solenoid here, homemade solenoid, and this is just a stand. I am using it as a stand to keep this solenoid vertical. So, if I put it here, it just remains vertical, and then I have a power supply, and from this power supply I will be giving alternative current to this solenoid. So, I connect it here, I connect it here, and the circuit is complete. The power is not switched on, but the circuit is complete. So, when I switch on the power, then current will flow through this solenoid and this AC current. So, the magnetic field produced will change with time, will create an induced electric field. Now, here is a wire, and I just put this wire around this solenoid and put a tape here, so that it does not fly away. So, here are the ends. So, it is a open loop, it is not a closed loop. So, it goes like this, and then these are the two open ends. And let me connect this multimeter here in voltage mode. This is connected here and this is connected here. So, it will read RMS voltage, it will read RMS voltage. So, the switch is not on, and whatever you are seeing is just a 0 error in the third place, 0.002 it is showing, but that is 0, almost 0. Okay. Now, I am switching on the power and you look at this display, what does it read? See, it is 0.034. Okay. Now, without disturbing that loop, that sellotape is still there, I take this multimeter to the other side. I take this multimeter to the other side, and then these wires which are here, let me put another sellotape to fix it. Now, look at this multimeter once again. Now, I am switching on the power and you see the reading of this multimeter, 0.007, very small as compared to the previous case where it was 0.03 or so. It is 0.007 here. So, that is the experiment. The EMF which is produced in this circuit is different, and once I put this multimeter on this side, it is different. And the explanation is pretty simple. If you have this solenoid here, and then you have current in the solenoid, and you have a loop here, open loop, you have an open loop here, and then you connect this loop this way. So, what do you see? You see that the magnetic field is changing in this area, and therefore, if I take this as the whole area closed loop, then you have an EMF. You have an EMF which is minus d phi dt or minus area dB dt. dB dt is because of the changing current in this solenoid. But once I bring this loop on the other side, if I take this loop on the other side from back side and it is like this. So, let me draw another cross section. So, I am now looking at from the top. So, the magnetic field is this way, of course, it is changing direction 50 times per second, and then there is a loop, this is that loop, open loop. So, these are the two ends, and then I connect my circuit this way, this is one condition, and you can see that there is a flux change in this closed loop, and therefore, you have an EMF, and that EMF is producing small current, and it is being read, the voltage is being read, voltage or whatever is being read. Whereas, in the second case, here the same solenoid, the magnetic field is changing with time and the same loop is there, this same loop is here, but this part, now this part is like this, now this part is like this. And now, if you look at the area, here is the area, and if the magnetic field is confined here, you do not have any magnetic field here, and therefore, no change in magnetic flux, and therefore, the EMF is 0. Of course, our solenoids are finite, so some magnetic field will be here, so some small EMF can still be there, but the essential phenomena has been displayed, that it depends on the area which is enclosed by the closed loop, and if the loop is not closed, then you do not know what is the EMF, that depends on how you close the loop. So, that was it.